For the video, I'm recording the bell work target 2 because it's so applicable to target 4. It's the basic concept. We've been studying functions and their inverses. And then in target 4 and 5, we're exploring exponential and logarithmic functions, which are inverse functions. So in number 8, we're not doing 7 and 9, keeping it condensed version today. The first step in finding an inverse is to switch the x and the y. All right, this is the important part for today. Just this one step or two. Switch the x and y. And then to find the inverse, you solve for that new y, right? You add 2, you take the square root. Okay, so we add 2 to both sides. X plus 2 equals y squared. We take the square root of both sides, and we get plus or minus the square root of x plus 2. So that is the inverse, and I use the word function loosely because we haven't determined if it is a function or not yet, but that is the inverse of x squared minus 2. All right, so then we go to graph, and I'm going fast to the bell work because we've already taught all this. This is just review. When you graph x squared minus 2, it's a parabola that starts at negative 2. Now the inverse. It will switch the input and output. It switches the x's and the y's. So if your starting point on that parabola was 0, where will the starting point be for the inverse? Switch the 0 and the negative 2. It'll be at negative 2, 0. So your starting point, negative 2, 0, will be somewhere in there. And it literally will flip over the x-axis, over the y equals x line, and it will look like a sideways parabola. Remembering all that? Okay. Is the inverse, that red sideways parabola, a function? Now you're already shaking your heads. No. Doesn't pass the vertical line test. And then again, domain and range, switching x and y. What's the domain of the original quadratic? What can you plug in to x squared minus 2? Everything, all real numbers. So then the next question I'm going to ask is what comes out of its inverse? What's the range of the inverse? All real numbers. Again, I switched the question. The input, I asked what's the domain of G, all real numbers. But now I'm asking what comes out of its inverse. The same thing, right? The point is it switches the input and the output. So back to range of the original. What is the range of the original? Greater than or equal to negative 2, right? X or y. It's y for range. Y is greater than or equal to negative 2. And what's the domain of its inverse? What are the things you can put under that square root? Greater than or equal to negative 2. X greater than or equal to negative 2. So the moral of the story, to find an inverse, you switch the and the input becomes the output, right? Okay, so then now, target 4, I've got a basic, easy question. Well, I say easy. We're going to introduce the concept of logarithm by taking 2 to the x equals y, an example of an exponential. I'm going to ask you to find inverse. What step and find which the x and y? So to find the inverse, 2 to the y equals x. Now, if it were x squared, we'd take the square root. If it were plus 2, we'd subtract 2. Those are inverse operations, right? What's going to get that y out of the exponent? What are we going to have to do to get that y? That's the dilemma. That's why they created a logarithm. They had to have a function that would take the square root or the cube root or the fourth root or do something to get that y out of the exponent. And so they defined this to be equivalent to that. And what that means in this example is this. If you had 2 to the y equals x, your inverse function would be log base 2 of x equals y. In other words, the logarithmic function with a base 2, called a base 2, undoes what an exponent of y would do. It undoes exponentials. Now, the more you play with these two rules and this conversion tool, the more it'll make sense. Okay, right now it's too many letters, too many variables involved for it to really make sense, I think. So let's use it to rewrite a few exponentials into logarithmic form. All right, 7 squared, I'll circle the 7. We call that the base of the exponential situation. There's a base of 7 and an exponent of 2, right? So when you write it in logarithmic form, it will be log base 7. Log base 7. That's a subscript. Log base 7 of, well, let's see. If b is 7, the b is the 7, the y is the 2, the x is the 49. So over here, the x, that 49 would go there, that 2 would go there. So log base 7 of 49 equals 2. And again, that word base was used for exponents, and it's base 7 in the logarithm as well. Base 7. Number 2, rewriting that in logarithmic form. The 4 is the base, so log base 4, and it's subscript, kind of like you remember arithmetic sequences and series. A sub 1, first term, A sub 2, A sub 3. It's the same kind of subscript. So log base 4 of 64 equals 3. And then, and by the way, we should be kind of talking a little bit about this. What is 4 cubed? And number 2, what is 4 cubed? 64. It's a true statement, right? What about the next one, number 3? 81 to the half. The square root of 81. 81 to the 1/2 power square root of 81 is equal to 9, right? Okay. So log base what? Base 81 of what number? Of what input value? Of the input value 9 would give you 1/2. All right, now let's go backwards. We'll also have to introduce a new vocabulary word, but let's go backwards. Take a logarithmic expression or equation and turn it into an exponential. I like to personally start by looking at the 2 and the 3. 2 cubed, yeah, equals 8. So what's the dilemma in number 5? There's not a base. It's called the common log. If you've worked in chemistry, you may have worked with the common log or even natural log, ln. Some earlier in second period had. Not ringing a bell with you all? No? Okay. Well, the log button on the calculator right there next to the 7 is base 10, just like your number system. Like the decimal 0.1, the decimal 0.1 is 1/10. The decimal 0.01 is 1/100th. You know, you work in a base 10 number system. What does a computer work in? What's its base? Base 2, binary code, right? Okay. So anyways, this, bless you, the calculator works in base 10. So when you hit log of 100, it's base 10. So in exponential form, when there's not a number written in the base, it's implied to be 10. It's called, again, common log, common logarithm. Base 10. So in exponential form, it would be 10 squared equals 100. All right, moving a little faster. I don't think you really need all of these examples that are in here, okay? 3 to the 4th equals 81. Is that true? 3 times 3 times 3 times 3 gives you 81? Yeah, okay. Last one, 16 to the 1/2 square root of 16 is what that means. Yes, that equals the 4th. Am I going too fast? All right. Then the last section, last part, evaluate a logarithm. And the way we do it is take the log and write it in exponential form and answer the missing question. So for number 8, the base is 5. So 5 to the what power will make 25 squared, right? So in other words, log base 5 of 25 is 2. So on the board, and they can't see this on the video, but the example was log base 4 of 16 on the board earlier. So 4 to the what makes 16? 2. So that answer is 2. And like I said earlier, it would be that easy once we go through the notes. All right, so moving on. Some of these will cause a little more trouble than others, but I'll go ahead and get them started. So what do you get? And some of you I can see are doing it mental math. That's fine, but they're going to get a little harder, I promise. All right, what's the answer to number 9? 2 to the what? 2 to the make 4. 2 to the fourth. 2 to the fourth will make 16. 2 to the fourth. So 4. Oh, you're looking at 10? Okay. 1/2 to the what makes 1/4? Yeah, to the 2, to the squared. All right. The next one that might give you a little trouble. 2 to the what makes 1/2? What kind of number takes a 2 and moves it to the bottom of the fraction, but keeps it 2? A negative number, a negative exponent. And now, do you want to change the 2? No, so -1. So the answer, -1. Log 10. Yes, we could grab the calculator and we could just say log 10, enter. But that'd be kind of cheating. The question's basically 10 to the what makes 10? 1. So when you think about it like that, it's easier to even do mental math. And last one, 5 to the what makes 1 over 125? Negative to flip it, yeah. Negative to flip it, and 3 to make it 125. So -3. All right, I'm going to pause the video and go on to the back. But your turn here. Actually, you pause the video here for 1 through 7. Try them on your own scratch paper, and then try 8 through 13. Pause it and try those. We're going to pause it here in class, and I'm just going to put the answers up here for you to check them. Okay. We'll do it one row at a time. So we'll answer 1 through 3 together, or check them together first. If you're having any trouble with number 1, I would start with what's on the board. 3 blank boxes, and then start filling them in. The first box I would identify would be the base 6, and put the base 6 into the log. And honestly, the way I think about it, 6 squared, that means that 2's on the other side. 6 squared, and of course 36 goes in here. Only look up if you want to check them. Honestly, I have to slow down on like number 3 and think about it for just a minute. 64 is the base. 64 is the base. The exponent's 1/3, so it goes over here, and the input into the log function is 4. All right, keep going with 4 through 7. Only look up if you want to check them. What's the base in number 5? Common log, so base 10, right? It's not there, it's implied, base 10. So 10 to the what? 10 to the -1 equals, I'll be honest with you, I'm not gonna write 0.1 even in that situation. When I see 10 to the -1, I think 1 over 10. Is that the same thing as 0.1? So it's okay if you put 1/10 or the decimal 0.1. You know, it's either one is the same. All right, there's some challenging ones here in 8 through 13. Don't want to ruin it. Give them a try. Mental math will suffice for a few of them, but you may need to use the template on a question like number 10. You might need to put 25 to the what makes 5 before you figure out the what, before you figure out the exponent. I'll go ahead and set up all of those exponential forms. good. All right, go over number 8. 2 to the what makes 8? 3, so you're right. Log base 2 of 8 is the answer 3. Number 9, 2 to the what? What's going to make it become a fraction? A negative exponent. What's going to turn the 2 into 4? Squaring. So yeah, I heard it. Negative 2. Good. What's going to turn a 25 in the exponent? What's going to turn that 25 into a 5? A square root is, right? A square root, which is the fraction 1/2. So 1/2. What's going to turn an 8 into a 2? What exponent will turn the 8 into 2? Yeah, 1/3. Cube root, 1/3. Now, when I go to set up number 12, I will not put the decimal 0.01 because I can't mentally, it looks better if I put the fraction 1/100th. Then it's a little easier to see why the calculator would say log of 0.01 is the answer, -2, because that's the exponent that makes that fraction. And then I should probably change 13 to make it more difficult, but 4 to the what makes 16? -2. You got it. You're good.